take a look at part B. So I already whoops. The second question is sorry, I'm adjusting the camera. It's hard to see all the work here. So the second part was saying they're trying to find how the angle of elevation from the camera is changing. So I put a little theta symbol right here. Because that's what we're going to be looking for. So what we're looking for is d theta dt. So the rate of change of this angle here. And what we're going to use is tangent. Tangent is opposite over adjacent. The reason why we're going to use tangent instead of like sine or cosine is because if I use sine, um, that would be opposite over hypotenuse, and these both have rates of change going on. So dB dt is changing, dC dt is changing, and then that's going to involve more math. If I use tangent, it's just one side changing and one is constant. So it's going to lessen our math work if we use tangent. So let's set this up. So I know that tangent of theta is equal to b over a according to the triangle, so opposite over adjacent. Next, I'm going to move the a over, actually let's substitute a already because a is constant, so let's do that. So tangent of theta is b over, and it was 4,000 feet. Now let's move the a, the 4,000 feet over, multiply both sides, just because it'll, make our math work easier. Now we got 4,000. Tangent of theta is equal to b. Now what we want to do is, because we're looking for the rate of change of the angle, let's take the derivative of both sides. I'm going to be doing d dt of both sides. Alright, so this will not become 0 because it's a constant in front of a function, so this does not become 0. You're just going to keep that in the front. So it's going to be 4,000. And if you remember, you probably don't have the little derivatives resource sheet that I gave you, of course, but you could also look it up on Google, be like, what is the derivative of tangent? In college, they kind of expect everyone to memorize what those derivatives are, but the derivative of tangent is secant squared x. So once I take the derivative, that's secant, well, instead of x, is secant squared theta. And because the angle is changing, we have to do d theta dt, so the rate of change right after it. And this is an equal sign. And now the derivative of b is just 1, right? The derivative of b is just 1, because it's like the derivative of x is 1, except we got to put dB dt right after it because b was changing. The rocket was moving up, so we need to put that there. Okay, now let's see what we have so far. So we're looking for this. We don't know this. We do know this though. So we know this one. dB dt was 600 feet per second. So let's just already put that there. But we don't know what secant of theta would be. Secant squared of theta would be. So here's what we have though, at least. We do know that tangent of theta is equal to the b over 4,000, and b at that point was 3,000 feet. So what I'm going to do is I'm going to say, okay, so tangent of theta is equal to 3,000 over 4,000. And that's, and that simplifies to 3 over 4. So tangent, I know tangent of theta is 3/4. Now, something that colleges also expect math students to have in their brain is the Pythagorean identities. So last year, or the time we were with me, we learned about the 3 Pythagorean identities. One of them was sine squared theta plus cosine squared theta equals 1. Then there was, if you divide all of this by sine, it's going to be 1 plus cosine over sine is cotangent squared theta equals, and then sine equals secant squared theta. There's another identity. That one I got by dividing everything by sine. And then there's the third one. So the third one is if you divide this by cosine, you're going to get, so sine over cosine is tangent. So tangent squared theta plus cosine divided by cosine is 1 equals, and then 1 over cosine is secant squared theta. So the identity that I'm going to use is this third one, because if I know tangent is 3/4, then I will know what secant is. Because if I know tangent, I'm just going to substitute into this identity, I'll know what secant is. So woohoo, let's do that. So tangent is 3/4. Maybe 3/4 squared plus 1 is equal to secant squared theta. So we're going to square top and bottom. So that's 9 over 16 plus 1 is going to be equal to secant squared theta. So 9 over 16 plus 16 over 16 is secant squared theta. 9 and 16, I believe, is 25. And I mean, you could already, like, square root both sides to solve for secant. Oops, sorry. There you go, my bad. So there's me solving for secant. So you could square root both sides and get rid of this square right here and solve for secant. Or I could already see that I could plug in secant squared up into the original that I wanted already. So I could just already plug in 25 over 16 right there. And then I'll be able to solve for d theta dt. Now I kind of wrote a lot, so let's see if I could move at least to the side here, my paper. There we go. All right, so we just figured out what secant squared theta was. So I'm going to just substitute everything right here. So secant squared theta is 25 over 16. And we have d theta dt, and then 1 times dv dt. So dv dt was, and I got to look back at that picture because I forgot, 600. So the rate of change was 600 feet per second for dv dt. I mean, I guess we don't have to worry about the feet per second for now. So now let's go ahead and multiply all this out. So 4,000 times 15 over 16 in the calculator. I got 6250 d theta dt is equal to 600. Now to solve for the theta, the change in theta over time, let's divide by 6,250. That goes away. So now we're going to have the derivative, or the rate of change of the angle of elevation, or theta, solves for. So, I mean, I know we could cross off a 0 here. I'm trying to simplify this so it's like a fraction. Let's see, maybe, I know 5 goes into top and bottom. I mean, I know it's going to give us a decimal, but I'm trying to simplify the fraction. I don't know if your school wants you to simplify your fraction or not. So let's see, 125 and 12. I'm pretty sure. I don't think anything else goes into this. 25 times 5, and then it's 12. Let's see. Let's see what the decimal version of that would be. So if you were to calculator, 12 divided by 125, that is 0.096, and it will be in radians. And again, remember in college, we never really work with degrees. We work in radians. So that's why your answer for B would be in radians. So there we go. The hard part about this problem, I believe, is, let's see. So one of them was remembering these identities. Another one could be also remembering that the derivative of tangent is secant squared, which is something they kind of think everyone remembers. And let's see. Other than that, though, the rest is algebra, like solving for a variable kind of thing going on. But yeah, I'm hoping that was helpful.